Greetings to professors and teaching assistants.
My name is Himangshu Shekhar Deka and my entry number is 2021 MS10886.
My elp101 project will be on the complex system op-amp. Op-amp or operational amplifier is a high-gain electronic voltage amplifier. It is an 8-pin integrated circuit with 4 pins on either side. It is used to amplify the input signals, invert the input signals, find the difference between two input signals, create low or high pass filter, make integrators and differentiators. This is op-amp circuit symbol. This is a typical op-amp. The op-amp generally used is IC741, which has 7 functional pins, 4 pins capable of taking input and 1 output pin. A circle is observable on the top side of the op-amp, which indicates that the adjacent pin is pin 1. These are the pins of op-amp. Pin 1 is an offset null. Pin 2 is an inverting input. Pin 3 is non-inverting input. Pin 4 is negative voltage supply terminal. Pin 5 is offset null. Pin 6 is output, where the voltage at this pin depends on the signals at the input pins and the feedback mechanism used. Pin 7 is positive voltage supply terminal. Pin 8 is offset null, which is a dummy pin not used to connect any circuit inside 741 IC. Voltage between pin 4 and pin 7 can be between 5 volt and 18 volt. Offset nulls are used to apply an offset voltage to nullify the effect on the output because of the high gain provided by 741 op-amp. There are two rules to follow when dealing with operational amplifier. No current flows into the input terminal. The differential input voltage is 0, that is, voltage at pin 2 and pin 3 must be equal. However, practically it is not possible because the junction of the input and feedback signal is at the same potential as the positive input, which is grounded. Then the junction is a virtual earth. Because of this virtual earth node, the input resistance of the amplifier is equal to the value of the input resistor Rin, and the closed loop gain of the inverting amplifier can be set as a function of the ratio of the two external resistors. Inverting amplifier. In an inverting amplifier, the output voltage changes in an opposite direction to the input voltage. Applying KCL at the node 1, we get the following equations. In plus If equals to 0, which implies Vin divided by Rin plus V0 divided by Rf equals to 0, which implies V0 is equal to minus Vin into Rf divided by Rin. If Rin is equal to Rf, then the gain of the amplifier will be minus 1, producing a complementary form of the input voltage at its output as Vout equals to minus Vin. This configuration is called a unity gain inverter or an inverting buffer. This is inverting amplifier circuit symbol. Non-inverting amplifier. In a non-inverting amplifier, the output voltage changes in the same direction as the input voltage. Applying KCL at node 2, we get the following equations. If equals to I1, V0 minus Vin divided by Rf equals to Vin divided by Rin, which implies V0 is equal to Vin into 1 plus Rf divided by Rin. If Rf equals to 0 and Rin equals to infinity, then the gain of the amplifier will be 1, producing Vout equals to Vin. This configuration is called a unit gain buffer or a voltage follower. This is non-inverting amplifier circuit symbol. Integrator. By replacing the feedback resistance with a capacitor, an RC network is obtained which is connected across the operational amplifier's feedback path, and this modification results in integrator. The output voltage is proportional to the integral of the variable input voltage, that is, it is determined by the length of time. Input voltage is present while the current through the feedback loop charges or discharges the capacitor. This is integrator circuit symbol. Differentiator. By replacing the input resistance with a capacitor, an RC network is obtained and this modification results in differentiator. The output voltage is proportional to the input voltage's rate of change with respect to time. This is differentiator circuit symbol. That's all. Thank you.